Hey everyone, Mr. Voikin here, and we are on Unit 6, Lesson 1, and we're looking at factoring now. So the previous unit we were doing what we call expanding. So we were taking sort of two polynomials, say two binomials, multiplying them together and coming up with a trinomial. Now we're going to be looking at a binomial or a trinomial or a monomial for that matter, and trying to factor out anything that is common. Okay, so let's take a look at this class example number 1, where it says do prime factorization for 8x squared, y squared, and 20xy cubed, and then determine the greatest common factor of those two. So we need to break those monomials there that were given down into its prime factorization. So let's do that for the first one. We have 8x squared, y squared, and if we break the numerical value down there first, 8 breaks down into 2 times 2 times 2, which is 8. So I have completed breaking that one down using prime factorization. And then the x is going to break down into times x, and the y would be times y, and we've now sort of separated all those into its lowest possible form. Okay, so let's take a look at the next one, which is 20xy cubed. Now, 8 was simple, it's just 2 times 2 times 2, and 20 is quite simple itself, but remember with the prime factorization, if necessary, I'm going to use one of the methods that we learned earlier to break that down into its prime factors. So if I take 20, I can see 2 goes into there, leaving us with 10. I can see 2 goes into there, leaving us with 5. 5 goes into there, I'm down to 1. So basically, the number 20 breaks down into 2 times 5. There's only one x and there are 3 y's. So now it says, what is the greatest common factor? Well, I got to find out what is common within these two right here. So I can see that there's a 2 and a 2, a 2 and a 2. There's a 2 up here, but there is not one down below, and there's a 5 right here, but there is not one up top, so those are not common. I have a common x. Again, this x is not common, and I have 2 common y's. It looks like I forgot to put the third common y right there. So essentially I've got those are common, and that is not common. Let's use some different color there so stands out a little bit better. Okay, so now what we need to do is take the greatest common factors, which is 2 times 2, which is 4. And how many x's were common? 1x and y squared. That is our greatest common factor between those two monomials. Okay, the class example 2, it's just basically saying determine the greatest common factor for each of these sets of monomials. So let's just go through it really quickly. A, on 12ab, what does this break down into? It breaks down into 2 times 6. 6 breaks down into 2 times 3, and I have a times a times b. And the other part of that was 15a squared b cubed. And 15 breaks down into 3 times 5 times a times a times b times b times b. And now what is common? Well, the 3's are common, the a's are common, and a b is common, giving us a greatest common factor of 3a b. Okay, now let's move on to the second one, which has 18x 4y2 and negative 24x cubed y to the power of 5. So on these simpler ones, I don't really need to expand that out into its prime factors. I don't need to prime factorize that. I can just look at these two numbers right here, 18 and negative 24, and what is the largest whole number that can go into each one of those. Well, I can see that 2 goes into 18 and 24. I can see that 3 goes into 18 and 24. I can see that 4 goes into 24 but not 18. 5 goes into none of them. 6 goes into both of those. And then if I get up into a 9, it doesn't go into 24. So it looks like 6 would be the largest numerical value that would go into both of those. So I can just say the greatest common factor is going to be a 6, and I've dealt with pulling them out of the greatest common factor of those two. Now, how many x's are common? Well, there are 3 x's on this bottom one right here, and there's 4 up here, so really we only have 3 common x's. And how many y's are common? Well, I've got a 2 and a 5, so we only have 2 common y's. Okay, and let's move on to the next one. C, what does it say here? I have a cubed bc squared and 2ac to the power of 7. So what is common on both of these? Well, you can see on the first one we don't have a number in front of the variables right there, so there is sort of a 1, but we're not going to write that down. So there's no common number. How many a's do I have? Well, the most I have in one of these is 1, so an a is common. And what about b's? Are b's common? No, there's a b in the top one but not the bottom one. And with c's, I've only got 2 of them that are common between the two, so the greatest common factor for this one is going to be ac squared. Okay, and the fourth one, which is D, basically we're just, instead of looking at 2 of them, we're trying to find something that's common between all 3 of them. So negative 40 a cubed b, negative 20 a squared b cubed, and negative 10 a squared b squared. Okay, just make sure I wrote that down correctly. I did. Now notice that in this case all 3 of those have a negative number right there. So basically I can pull out a greatest common factor of a negative number, and we want to pull those out if we can. So what's going to be common between all 3 of those? Negative 10. So I've now dealt with all the numbers. What is common on the a's? Well, I got 2, 2, and 3, so it's going to be a2. Just use the exponent that is the smallest. And for the b's, I've got 2, 3, and 1, so it's going to be 1b. And I don't need to write the 1 there, just leave it as so. Okay, for class example 3, you can see that what's basically happening here is they're saying we started off with 21x plus 14y. So we start off with this binomial and we're left with this. So we pulled something out. We factored something out of there. So what did we factor out of there? Well, I have to take a look and see, well, 21 divided by 3 is going to be 7. And 14 divided by 2 is going to be 7. So you know that we pulled out a 7. Now I want to take a look at the variables as well. I had 1x and 1x, so the x is still inside there, so we didn't pull an x out. I started with 1y, ended with 1y, so again, I did not pull one of the y's out, which means the only thing that I factored out of that initial binomial was the number 7. So let's take a look at the second example, B. Okay, so I've got a number right here, which is 5, 15, and 5. So again, the number in front of what we have after we have factored it is a 1, a 3, and a 1. So if I just take 5 divided by 1, I get 5. If I take 15 divided by 3, I get 5. If I take 5 divided by 5, or 1, I get 5. So what did we pull out of there? We pulled out a 5. Now, did we pull out any of the variables? Well, what did I start off with? I started off with 4 x's. I ended up with 2 x's. So how many of the x's did I pull out of there? I pulled out 2 of the x's, so an x squared. Does that work out the same for all the other ones? Started with 15x cubed, 3. I only have 1 left, so I pulled out 2. And on the last one, I started with 2, and I have none down there, so I also pulled out 2. So essentially what we've got here is I factored out a 5, but not only a 5, I have factored out a 5x squared. Okay, class example 4. In each case, a greatest common factor has already been pulled out, and it says complete the factoring. So we started off with this binomial right here, and we've pulled out or factored out a 5a. So it says, well, there's at least an a left in here, and what else would go right here? Okay, so let's take a look at this and say, well, if I started with a 5a squared and I pulled out a 5a, I'm left with 5 divided by 5, which is 1, and a squared divided by a, which is a to the power of 1 right there, but I don't denote that 1. So I'm going to move on to the second part of this binomial. 25 divided by 5 is going to be 5. And I had an a to the power of 1 divided by a to the power of 1 is going to be 1 minus 1, which is 0. So a to the power of 0, which we don't write that down. So this is the final answer right here. Factoring that out, it becomes 5a times a plus 5. So let's move on to part B. We started off with this binomial, and it says we've factored out a 2. So a 2 is what was common in there, and what are we left with? Well, again, 18 right here divided by the 2 is going to leave us with a 9. Now, we didn't pull out any variables, so that p that was in there would still stay in there. And if we just verify and check the second one, 16 divided by 2 is going to give us the 8, and the q is not pulled out, so it remains right there. And don't forget, the negative stays where it was. We didn't pull out anything negative. Okay, and let's move on to the third one, part C. So I've got negative 4mn minus 6m squared, and what did we pull out? We pulled out a negative 2m. So if I pulled out a negative 2m, what do I have remaining? Well, negative 4 divided by a negative 2 leaves me with a positive 2. I also pulled out 1m. There was 1m to start with, so those are gone. And the n was there. I didn't pull out an n, so that is still inside those brackets. Now, again, I've got a negative 6 right here, and I divide that by negative 2. So what do we have? We've got a positive 3, and the m, I started with an m to the power of 2. I pulled out one of those m's, so I'm still left with 1m. So it's basically going to be negative 2m was what we factored out, leaving 2n plus 3m. Now, once we get a little bit more complex like this, we can do a check to verify if we are correct. So all we have to do is expand what we just factored, and if it goes back to the original, then we're looking good. So we're basically saying if I take negative 2m, multiply that by 2n plus 3m, I should get what I started with, which was negative 4mn minus 6m squared. So let's check to see if that's the case. So here we got negative 2 times negative 2, which is going to be negative 4. I've got an m times an n, which is going to be mn. I've got a negative 2 times a positive 3, which is a negative 6. And I have an m times an m, which is going to be m squared. And now I look at these two right here and I see they're identical, so my check verifies that I factored that correctly. Okay, and the final one, it says that we have pulled out a 9x. So if I divide the 18 by 9, I get 2. I divide the x squared by the 1x, which is going to leave me with 1x, and I still have the y squared in there. I take the negative 45, divide that by 9, I got negative 5. And x divided by x, those are gone. x1 divided by x1 is going to be 1 minus 1, which is no x's, but I still have that y right there. And the last one is 9x divided by 9x, which is a positive 1. And that is our final answer right there. And again, what I would do is I would take that and do my check to make sure that I did it right. Okay, number 5, we'll look at A, and it tells us to take this binomial and we're going to factor it. So we're going to factor it, which means we're going to pull out whatever's common, leaving whatever is remaining. So I can see that within both of these terms within this binomial, the only thing that's going to be common is going to be a 2. So that means I'm pulling out a 2. So this is the same as or equals 2 times whatever's going to fit inside this bracket. 20 divided by 2 leaves me with 10. I didn't touch the x. And negative 6 divided by 2 leaves me with a negative 3. So this one right here, if I was to expand that out, it should check and verify that I did that correctly. Let's move on to part B, which says 16x to the power of 4 plus 4x squared. What does that equal? Well, what is common first? I can see that a 4 is common and an x to the power of 2 is common, leaving what? Well, let's deal with the first term. 16 divided by 4 is 4. x4 divided by x2 is x2. Positive 4 divided by positive 4 is positive 1, so I don't write down positive 1. And x squared divided by x squared is 1, so I do, in this case, have to put a 1 right there because there is no variable. So basically what we've got is 4x squared divided by 4x squared, and anything divided by itself is 1. Part C says 10a cubed b squared plus 8ab cubed plus 2ab to the power of 4. Okay, I'm just going to shrink this down a little bit because we're going to run out of room. Recess. Okay, so again, the first thing I'm going to do is I'm going to say, well, that equals, what can we pull out that is common? I'm going to pull out a 2. And how many A's do I have? Well, I've got 3 A's, 1 A, and 1 A, so only 1 A is common. How many B's do I have? I got 2 B's, 3 B's, and 4 B's, so 2 B's are common, leaving whatever is left inside this bracket. So let's go to the first term in this trinomial. 10 divided by 2 is going to be 5. a cubed divided by a leaves an a squared, and b squared divided by b squared is basically 1, which is not going to change anything there. I don't need to identify that. Let's move on to the second term, 8ab cubed. So I'm going to deal with the number first. So 8 divided by 2 is going to be a positive 4. A divided by a is basically 1. So I've already got the 4 there, so that's not going to change anything. And b cubed divided by b squared is going to leave me with 1b. b to the power 1. And the last term right here, we can see that 2 divided by 2 is a 1. I only need to write down the 1 if there's not going to be a variable after that. A's are going to cancel each other out again, but you can see that b to the power 4 divided by b to the power of 2 is going to leave us with a b squared. And again, just to verify you're doing it correctly, you would want to expand that and end up with what you started out with right there. Okay, and let's move on to part D. And part D, we're starting with 12p cubed minus 6p squared plus 15p. Okay, well, that equals, well, what is the common number that I can pull out of there or factor out of there? I can factor a 6 out of the 12, a 6 out of the negative 6, but I can't factor a 6 out of the 15. I can factor a 3 out of the 12, a 3 out of the 6, and a 3 out of the 15, so I'm pulling out a 3. I've got p to the 3, p to the 2, p to the 1, so I'm going to pull out 1p, leaving us with what inside the brackets? Well, 12 divided by 3, 4. P cubed divided by p, p squared. Negative 6 divided by a positive 3 is a negative 2. P squared divided by p is 1p. And positive 15 divided by 3 is a positive 5. P divided by p, they basically cancel each other and end up being just 1. And that is what we're left with right there. And holy man, look at the next one. It is big and complicated, but it is the same process. Let's move it over here a little bit. 25xy squared z to the power of 3 minus 20x squared y for z or z to the power of 2 plus 30x for y2 z 5. Okay, well, with this one, I think I'll just say it equals and put it below because I'm running out of space over here on the right-hand side. Let's deal with our numerical coefficient here. So what do I have? I got 25, 20, or negative 20, and a positive 30, so I can't pull out a negative number. I'll pull out a positive. Looks like the common numerical value that we can pull out is going to be a positive 5. I don't know why I wrote plus, just pull out the 5. How many x's do I have? 1, 2, and 4. So each of those terms within this trinomial has an x, and the one with the lowest degree was a degree of 1, so there was only one x. What about the y's? I got 2, 4, and 2, so the lowest degree in the y's was 2. And the z's, I got 3, 2, and 5, so with the z's, I pulled out 2 z's, leaving us what? First term, 25 divided by 5 is 5. X divided by x, dead. Y squared divided by y squared, gone. Z cubed divided by z squared, leaving 1 z right there. Move on to the second term. Negative 20 divided by 5 is going to give us a negative 4. X squared divided by x is going to be 1x. Y4 divided by y2 is y2. Z squared divided by z squared basically cancel each other out. Move on to the third term. 30 divided by 5 is a positive 6. X4 divided by x is x3. Y squared divided by y squared is gone. And z to the power of 5 divided by z squared is going to be z cubed. Close the bracket. expand it out and check if we're correct. Okay, we got the last class example here, and it's saying we got this cone and it has this formula right here where the area equals pi r squared plus pi rs. So you may recognize that area, basically what we've got here is this binomial. So because I have a binomial, I should be able to pull out some common elements within the terms if possible. So part I says determine the surface area of the cone to the nearest 1/100th in centimeters squared if the slant height is 7.4 and the base has a radius of 2.6. So we'll just take our original formula right here, which is area equals pi. Yeah, I don't need that bracket right there. Pi, which is just pi, r, which is going to be 2.6 squared, plus pi times r, which is 2.6, times s, which is 7.4. And now just give me a second. All I really have to do is just punch this entire string right here into the calculator as I see it. So pi bracket 2.6 bracket squared plus pi bracket 2.6, close and open another bracket, insert a 7.4, close that bracket, hit enter. I have a total of 81.6814, and it tells me to round that to the second decimal place, which means I only want to go that far. I noticed that the to the right of that, it's a 1, so it's going to stay the same. So the answer here is going to be 81.68, and the units are centimeters squared. Now it says, hey, take that formula and factor something out of there. So what can I factor out? Well, A is going to equal to, well, notice that within that binomial, I've got the two terms. There's an pi and an r in each one of those terms. So I'm going to pull out a pi, and I'm going to pull out an r. What's that going to leave me with? Well, 1r in the first term, and it's going to leave me with an s in the second term. So now part 3 is saying calculate the surface area of the cone to the same precision, except using this factored form that we just created right here. So I will do that. Area equals pi times r, and r was 2.6, and times an r inside, which is going to be 2.6, plus the s, which is 7.4, and close the bracket. And now I just need to shove that back into the calculator again. So pi bracket 2.6 bracket, open another bracket. Inside we've got 2.6 plus the 7.4, close the bracket, and I get the exact same answer. It equals 81.6814, which would get rounded to 81.68 units of centimeter squared. And we're done. All right, you guys. Well, here is our at-home assignment. I just got 2 questions. Second question has 2 parts or 2 examples in there. First one, I just want you to take that trinomial right there and determine the greatest common factor. So just find the greatest common factor. In part 2, we want to factor it completely. So we should end up with this equals sort of something that is pulled out, that's factored out, and whatever else is remaining. So on the first one, I've got negative 6x squared minus 9x. And the second example is 5x squared minus 10xy minus 20xz, and bring those questions completed to class. And in class, we will be working on all the questions, pages 324 to 328.